Welcome to EDU World Space.
So let's say we have a coordinate plane and here we have two charges and these two charges are having magnitude q and they are positioned at one, let's say it is positioned at L0 and another q charge is positioned at minus L0. So we need to find out the electric field at any point on the y-axis. So let's say this is at y distance from the origin, so this point will be 0y. And here if we find out the electric field, so due to this charge, the electric field will be in this direction, and due to this charge, electric field will be in this direction. So the magnitude will be same because the charge and the separation is same. So let us find out one electric field. So that will be K Q by this separation square. So this is L and this is Y. So separation will be root of L square plus Y square by using Pythagoras rule in this right angled triangle. So this square will be L square plus Y square. So that is the electric field E. So this will also be E. But due to symmetry here, this, if we take it as theta, this also will be theta, and this also will be theta, and this also will be theta. To find out the net electric field, let us project the electric fields. So if you project this electric field, it will be E sine theta in this direction and E cos theta in this direction. Similarly, the projection of this electric field will be E sine theta in this direction and E cos theta, so that will make it 2E cos theta. So these two electric fields will be cancelled and we get the net electric field coming out to be 2E cos theta. So this is the net electric field. So let's put the value of E here. So 2E was KQ by L square plus Y square. And for cos theta, let us take the use of this triangle. So it will be base, that is Y, over the hypotenuse, which is root of L square plus Y square. So if we simplify, we are getting the net electric field as 2kqy by L squared plus Y squared raised to 3 by 2. So this is the magnitude of the net electric field, and we are observing that this net electric field is along y direction. So this is, let us take this complete value as E dash. So we can say that net electric field is E dash if y is positive, and it is, so let's write the direction as well because this is a vector, and minus E dash j cap if y value is negative. That means if the point is lying below the origin. So let us find that point where the electric field is maximum. So what we do here, we take the expression of electric field and differentiate this d of E net with respect to y, and we put it at 0. So we do d by dy of the electric field expression 2kqy by L squared plus y squared raised to 3 by 2. So here we don't deal with the denominators because anyways if it is equated to 0 then it will be cancelled. So let us just take the numerator because if we have u by v and if we differentiate we're gonna get u dash v minus uv dash by v square. So we'll not care about this. We'll just frame the numerator and equate it to 0 anyways. So u dash v. So if we differentiate numerator, we get 2kq. Y differentiation is 1 into L squared plus Y squared raised to 3 by 2. And then minus 2kq y times the differentiation of denominator, that will be 3 by 2 times L squared plus Y squared raised to 1 by 2 into the differentiation of inner part, that is 2 by. And if it is equated to 0, that means one term will go to the right. And let us cancel the terms. So yeah, we can cancel this root as well. So from 3 by 2, root of L square plus Y square will be cut. So we'll have only the power as 1. So we'll get L square plus Y square is equal to 3 by 2 into 2y square. So this makes L square plus y square as 3y square, and this gives us L square as 2y square. So from here we can figure out y square, that is L square by 2. So y will be plus minus L by root 2. So this is the point on y-axis from the origin where the electric field intensity is maximum.